All right, so basically what I'm here to show is how to supply a GPU cluster to the Hyperbolic network. So the first step is to go to app.hyperbolic.xyz/supply and make sure you're logged in. And of course, that you are in our allowed suppliers list. So currently we have a wait list for suppliers, just as we are still in beta and growing the ecosystem. This is necessary for us to ensure stability and quality while we roll out reputation systems to smooth out the user experience on the buy side. So if you're seeing this, it's likely because you are in the supplier allow list. If you're seeing this and you're not in the supplier allow list, my apologies. We are working to open up the supply to the public soon. So given that you are here, you should be able to see the supply compute instructions. Basically, this refers to our GitHub. Hyper-dOS is our distributed operating system, and you're always welcome to come to our GitHub, though you may find some of the documentation around our site to be a little more supportive, but especially if you're interested in filing tickets, issue support requests, that kind of thing, or feature requests, bug fixes, and especially PRs. We very much appreciate those. If there's anything you'd like for us to update in our install script or more generally in the operating system, or distributed operating system, I should say, because this operates on Kubernetes, not on an individual node level. So basically what this script does is takes you from an individual node level, aka server or bare metal or what have you. In my case, it'll be a small EC2 instance with a basic GPU setup. And it will take you from that world of node and server, right, single entities of computation, into our world, which is cluster first. And the install script is sort of the basic way to do that. And what it is it'll take you from a basic Ubuntu server and create a single node Kubernetes cluster that has persistent storage setup and some of the basic network connectivity that we need to orchestrate your cluster and ideally make the most amount of money on your behalf using as much of that computation as we can and feeding it into our buy side. So as you can see, it's a one-line install. What that one line is doing is going and downloading the bash script from GitHub and then running it. You are very welcome to check out, inspect, and verify that there's nothing crazy going on in this script. Basically, what it does, as you'll see, is install microK8s, which is a nice, simple IoT Kubernetes distribution from Canonical, the same people who make Ubuntu, among some other nice bits of software. And it installs microSeph, which is a cluster storage layer that is really useful as we provide the buy side with persistent storage functionality so that they can access, some large amount of data as they make use of your GPUs. And so we'll go ahead and run this. I've got a EC2 instance set up just as a nice little demo. So you can see this is running fresh install of Ubuntu and has a simple T4 GPU. And we have reached the point where, NVIDIA drivers are up and working. And this is now where we can run the install script. So I'm going to be demoing the hands-on install script to take a single node into a single node cluster, right? Now, for those of you that would like to automate things more, and that makes a lot of sense, especially if you're trying to install Hyper-dOS on, say 1,000 disparate nodes. We do have a headless mode. Reach out and we can show you how that works. It's also documented in the GitHub. So in this case, we're going to do it on a single node and just follow the main line that you would follow maybe the first time running a test installation to make sure everything works. So there's that script. I'm going to run it, and it's going to ask me if I want to install microcates. I'm going to say yes. Hopefully that goes through smoothly. If it doesn't, again, feel free to reach out. We do make some assumptions that you have Snap installed and that you're running on Ubuntu. However, we would like to be much more distro agnostic. This all can work on macOS and Windows, but we just don't have that built into the script yet. Again, pull requests are very much welcome if you would like the script to support macOS and Windows, or whatever your particular distro is. I, of course, am a big fan of Arch Linux, and the script more or less works if you have Snap set up in Arch Linux. But yeah, feel free to run it anywhere, and if it doesn't work, shoot us whatever additions you'd like to the script in a pull request, and we'll add them. So the next step is it's going to ask us to install microceph. Again, this is the storage layer. Basically, it'll set up a block storage system that is somewhat cloud native and is going to work nicely with the Kubernetes cluster. Now, basically, it's going to do a bit of basic setup on the cluster, get the cluster bootstrapped, create a few namespaces that we're going to use, and then it's going to move on to setting up the microceph system. So what it's going to ask now is how much of the root disk you would like to allocate to Hyper-dOS. And if you have less than 100 gigabytes, it's just going to be a little awkward. So keep in mind, this should usually only be installed on systems where you have at least 100 gigabytes of free space on top of what you want to allocate to Hyper-dOS, which we suggest is at least a terabyte. Now, in this case, I'm running it on a small machine, so I'm going to go ahead and say, I see, all right, the estimated free space is 145 gigs. Keep in mind, this is decimal gigs, not binary gigs. So the estimated free space is 145. I'll leave 100 gigs free, so let's say 45. And keep in mind, if you were to set 45 gigs aside, likely your system wouldn't be rented. A lot of the buy side requires a much higher amount of persistent storage than that. So I'm leaving aside 100 gigs for the system to work with, and then I'm setting 45 gigs for the users to work with. So now that's going to allocate a virtual disk. It's going to rig that disk up to microceph and configure it in a single replicated block storage pool. If you want to run custom microceph setups, you're welcome to do so. Just keep in mind it's a more advanced option. We're happy to help with some of the more straightforward tasks in microceph, like, for example, if you would like to bring external disks into your supply cluster, just ping us and we're happy to help. And we'll add some documentation to the README on that, as well as hopefully some scripting in the future to make it simple and hands-off, but relatively straightforward. So now what's happening is more cluster bootstrapping, and Argo CD is a core component of how Hyper-dOS works as a cluster operating system. So it's just waiting for that to get set up in the cluster. And pretty soon when that works, it's going to actually go ahead and install Hyper-dOS itself into the cluster, right? So now this is the install script, not Hyper-dOS itself that we're running. Hyper-dOS is a distributed operating system, which means that it lives in a world of clusters, not computers. So the way we deploy that is through Argo CD, which is a continuous deployment. So now it's going to ask you as it runs for your API key. That API key can be retrieved from your settings page. You can copy it and you can paste it, hit enter. Keep in mind the text will be hidden, and it's going to just check that the API key is valid. And here we go. All right, now it's going to install Hyper-dOS into the cluster. So there it is. So that ran smoothly, and you get a nice little hyperbolic ASCII art and a welcome to the rainforest message. So basically, now that the installation is complete, you should be able to view the cluster at our supply dashboard. Keep in mind, it might take a little bit just for all the new information to propagate the system and for your cluster to pass a few of our intake tests just to make sure that the compute is working and the networking is working and everything's all configured and set up before opening up the cluster to be rented by the general public. Now, we do have a level of isolation between your system and the general public, which is important. And you can read all about that in the container security models and Kubernetes security models. I just want to make sure that we're clear that, there's no, this is the world of software, and we want to make sure not to put anything super critical. And at the beginning, it's going to be untrusted, and then it's going to go through our system and eventually progress to the semi-trusted tier, ideally. So you can see here, setting the price is important, right? So in this case, I actually want to lower it because I want it to get rented quickly. So I'm going to put it down to 9 cents an hour, just going to save that. And you'll notice that the market data is still populating because, this is not an instance that has, this is not a node that has a GPU that is very popular in our marketplace. The T4s, not a lot of people are supplying, obviously, because they're very small. So that's how you edit pricing. And then ideally, as it goes through a system, it should progress to become, move from untrusted into semi-trusted. And that takes a little while just because it takes some time for our system to test it and make sure everything is working, and just give it a little time to make sure it's stable on the network. Just make sure that over the course of, an hour or two, it doesn't go down at any point before we put buy-side users onto it. So on your end, I think something that's really useful is being able to work with the Kubernetes control plane. So this is an example of a command that gets all of the nodes in your cluster. So in this case, it's a single node cluster. So we should just see one node, and that's the demo Buffalo node that we've been working with. You can also get namespaces, right? And the Hyper-dOS namespace is very relevant to us. And you can also get, let's say, deployments in the Hyper-dOS namespace. So you can see we have this epitome deployment, and we're going to look at the epitome deployment using the kubectl describe command. and it's going to give us all this information. Now, as you can see, this is a little bit tricky to work through, right? Obviously, we've got here your Hyperbolic token and the gateway URL we're hitting, but it's kind of, it's not super user friendly. So what we suggest is to install K9s. Now, K9s is a text user interface that allows you to interact with a Kubernetes cluster. And you set it up by installing it and then running this command sudo microcase config and writing the output to your local home directory .cube/config. And at that point, K9s will know to go look in that file for the credentials to connect to your cluster. Be careful with this because it gives access to your cluster, so just make sure you're not saving this file anywhere unsafe. So K9s is this interface. So it's when you enter it, it might be a little overwhelming, but just remember that namespace concept from before. You go to the relevant namespace, so in this case, Hyper-dOS, and we have the epitome pods. Let's go and get the logs. So you can see up here in the top right, the command for seeing the logs from within the epitome pod is L. So you hit L and there we go. Everything looks pretty good. So if things weren't going well, you might see some errors in here and you could tell us what those errors are, and then we'd be able to fix your cluster for you. So just keep that in mind. Another thing is just to make sure that if you ever do end up making any changes to the amount of Ceph storage you want to provision, like let's say you add more disks, just make sure to go to resource quotas in the Hyperstore namespace. So you can see basically that this basically tells our system, our marketplace, how much of your storage you want us to use. And so that's going to connect to the microceph storage backend, and is going to limit how much the buy side is going to be able to consume your storage, which is good because if you don't limit how much they're going to consume your storage, they could overconsume the storage, and that would cause trouble in your Ceph cluster. So just generally, you don't have to do anything in the mainline, installing a single node cluster with the bash install script. But generally, if you're going to start to add more disk, which is a good way to make more money in the network, just make sure that you keep this resource quota up to date. And you can reach out to us to help with that if you like. So we've covered a bunch here. I think the big next thing is just going to be watching this untrusted go to trusted, and that does take some time. If it takes longer than a couple hours, just reach out to us and we'll be happy to look into why that's happening. I think that is probably all I've got for now. Yeah, good luck, and hope you enjoy working with Hyper-dOS.